Not really sure. It's like you could scale it. It should be scalable. Or you can scale it again. What's your exact thing
Cool. We made it back. 2 days last week, 2 days this week. That seems like a pretty good schedule to me. Like the three meetings, it's a lot. We'll get there. Nice to have a snow day, start off the semester. My kids were super excited. Even this morning, my son, he's like ready for school, but he's like, maybe there's a delay. Do you think there's at least a delay, like begging me, like, please, can you delay the school opening? I'm like, no, we're back to normal. Just hop on that bus, risk your life through the icy roads. So thanks for getting here through the ice and snow. And so we'll jump into, so first thing I wanted to kind of show, I thought about doing a, like recording a video for this, but I thought we could just like do it in class to see how it works and ask questions that way, of like going through this learning coach quiz thing. It's new, and this is like bleeding edge technology, so it's not gonna be smooth the first few times. Like as you get the hang of it, it does work, but it's definitely not a smooth like Apple iPhone experience. It's more of like strap in, get ready. You'll probably hit some errors, find some bugs, but that's okay. It's all part of the learning process. Sound like a good plan to start is like just try it out, see what happens. Initial questions before we even try it. Did anyone try it already? Tried it? Okay, not bad. Glowing review of 5 stars, not that bad. Yeah.
Sometimes I would like, I don't know, it would just like correct me on something that like I already said.
Yeah. Okay. So yeah, and I won't like teach you and like reteach you, because you probably used AI and you probably have seen videos of people that deal with AI, of like context windows and hallucinations. Like all these things kind of go into your interactions with AI. It can be a helpful tool. It can also be a huge distraction from the actual learning process. So just be careful with how you're kind of implementing it into your learning process. And one of the things that it'll do is it like forgets. Like you tell it like, hey, my name is Ryan, and talk. And then it's like, hey Bob, do you want this? It's like, no, I told, what, who's Bob? Like, where did this come from? Like it just, its goal is to get you to interact longer, not to learn something. It's not trying to teach you anything. It's not trying to like do anything novel. The main thing is the longer you're connected to that server, the more money they can justify putting into that server, and then they can go buy that power plant and like connect to it. So just be careful. So let's try this learning coach. When you click it, there's a link to this dynamics coach. So what should happen is it'll pop you into Copilot, and then it kind of blinks, refreshes. Usually what happens for most people is it will say like, hey, do you want to add something to your Copilot experience? And then once you click like add that, then it brings you to this thing, like, and it should say like created by Cooper Ryan. If it says something else, then I don't know who made it. I don't know where this thing came from. But this is what it should kind of look like by the time it starts working. This one's a weird hack, but if it didn't work, like you click it, you say yes please install this, and it still doesn't work, for some reason, if you come over to this sidebar and create a new agent, like any new agent, just you can do any. Have you ever tried creating like agents, the AI agents? No? Oh, should we do it? Make something. All right, so create a new agent. This can't, and this is all I did for this class, so it can be helpful for other classes. Like if you're like, hey man, I really like these on the fly quizzes that it's generating, you could do this for other classes. You can say create an agent, we'll configure it, say this is our Star Wars quizzer. May the force be with you. I don't know if description and name really affect it, but the instructions are the main thing. You are a seasoned Jedi, if I could spell, Jedi warrior training me, your Padawan. Padawan? Padawan? Yeah? Padawan? I don't know. Is there an I in there somewhere? Padawan? An E?
I think it's all A's.
It's all A's, right? Padawan? Padawan? And then we'll come down and we'll give it. What is it? What's the wiki for Star Wars? Star Wiki? No. There's a whole website, Star Wars, Wikipedia. Oh my God, I should have known that. Right. So we'll give it Wikipedia. So now it knows, like, yes, you're a Jedi. Here's some context, and let's create. And for some reason, sometimes this works. Like once you create an agent, then it's easier to like import agents. You don't have to. If you click mine and it just imports and works, then great, go for it. But if you want to try making one, then you can try it this way. You didn't know signing up for Dynamics that you'd get like an AI agent lesson, but here we go. This is the world that we live in now. You can't do your job without AI. It's like, that would be crazy. That'd be like coming to work without your slide rule. Let's go to my agent. How can I defeat Darth Vader? Not bad. My young Padawan. Wise question. We speak only of fictional Darth Vader. Yeah, okay. All guidance is in Star Wars lore. Okay, do not try to overpower him. Use the Force defensively, not aggressively. That's good advice. Otherwise, tend towards the dark side, as we all know. Attack openings, not the armor. Shoulder joints, control panel, respirator mask. That's dark. Like, go for his respirator? I guess it would work. That seems like this one's been compromised, though. 'Cause that sounds like the dark side of the Force. Mobility, do some flips, lateral movement like a crab. Oh, leverage an inner conflict. Again, this is pretty dark. But like attack his emotions. The goal isn't victory. Oh, your goal is to save others, destroy something, and live to fight another day. True Jedi knows the difference. So we have it seems to work. It seems to be referencing Star Wars. All right, so anyway, back to Dynamics Coach. You can either say, like, learn about something or test knowledge on those concepts. Like, so now that we have AI agents, we can say either teach me or quiz me. I'm gonna jump right into quiz and just see what happens. And all it's doing is like copy pasting that prompt into this conversation. Questions so far? It's just loading. How's it going? I've tried this before with another class that I teach with computational mechanics, and that one's really cool. Like I have a website full of all these like Python exercises and explanations and stuff, and it does a great job like grabbing Python code to and then explaining concepts there. So this one should be similar because there's also like Python projects in Jupyter Notebooks, so it should be looking at that to help try to explain this course. And I'm using all the anthropomorphized words because that's kind of the verbiage that we're used to. Really, I should be talking about like matrices and tensors and transforming like words into vectors and vectors into other vectors, but because it's not really doing anything. It's just processing information, and then it sprinkles in some random numbers in there to like change the information that it creates a little bit. So one question at a time, at least 4 questions, cool. No multiple choice. Easy. Kinematics, position, velocity. What is this position? What is the velocity as a function of time? What do we think? If x of t is 3t squared minus 2t plus 1, what does that tell you about position? What does that tell you? What is it? Ooh, initial position is 1. We could say 1 meter. Our AI is notoriously bad with units, so assigning units is very helpful from the get-go. It could be centimeters, like as long as it's consistent. So we need some consistent. So we've got initial position is 1. What's our initial, yeah?
Our initial velocity is just the derivative, 6t minus 2.
6, that's our initial, 6t minus
Our
2.
velocity.
Okay, velocity is 6t minus 2. I like that. So what's our initial speed? Yeah.
-2.
So it's moving backwards initially, and then something is speeding it up. And again, maybe it's centimeters, could be millimeters. I'd like to think that it's cubits. How many cubits we've moved? We're at 1 qubit, we're moving backwards 2 qubits per second. No, not per second, per, I don't know, something weird. What's a weird measure of time? I feel like we still use seconds. All right, so let's try that. 6t minus 2. Loading. Cool. Takes the derivative. This was also interesting with AI. Someone. This was maybe 2 years ago, so it's different now. But at the time, freeze frame AI. So AI doesn't actually do math. Like it can't do math for you. It will, if you say like what is 2 times 5, it converts that into a vector of like words and numbers, like what, and so the most likely thing to come after 2 times 5 is 10, and there's lots of data to support that in like documents and stuff. But someone created a multiplication table of like 1 through 20, 1 through 20, like what is 1 times 1, 1 times 10. And by time you got to the edges of like 15 times 17 and 19 times 18, all of those things, it could only get right like 25% of the time. Anything that's within the 10 by 10 tables, that one it's good at. But if you're asking like what is pi times 3.5, no, don't trust the answer. It's not going to know it because it's not actually calculating anything. It's using vectors. Okay, question 2, we have velocity. When do we move backward to forward? Okay, what do we think? We have velocity, and we want to know when we're going backward versus forward. Did anyone get the same questions here? Okay. Different questions. They should be different. Like there's usually something that makes them a little different once in a while. 0.33. Okay. Why do you say that?
That's when it switches to zero. The derivative, the velocity is zero.
Okay, so set v of t as 0, right? So when it's 0, there's got to be a sign change. First we're moving one direction, then we're moving the other. So when we say 6t equals 2, and here, look at that. It's even giving us an answer. So it says it's not multiple choice, but one of the options is an answer. Or I could say like, show how to solve for t, what does switching directions mean? So I'll grab that. Nicely done, but it gave me the answer. That part's a little weird. I don't love that. Again, as an AI, its main goal is to keep you engaged. So it's like, yes, nailed it. Like it's giving you like quick, easy things to say like, yeah, I'm really doing this. But it does help explain. So if you're going through this, I like to think of it as like, anytime sooner or later you have to copy and paste. Like you have to use someone else's work in your own work. There's just no way around it. There's no way that you can be an engineer and not like go through reams of like manuals and stuff and use those manuals to do your job. But every time you take something and copy it, put it into your own process, try to add something to it, like make it a little better in some way. And that's the best way that you can like maintain your own sane work environment, is copy, paste, improve. Always follow that process. So if you're copying and pasting, take a second, figure out what is it doing, why am I using this, why did everyone else do this in the past, and then try to improve it a little bit. Like everyone else thought it was this t equals 1/3, and like, well, there's no units here, so let me give it some units, assuming everything else is in meters or something. All right, so keeping on. 2 kilogram mass is moving along a line. What is the net force? I like this one. What do we think about this? We have 2 kilograms. We know its position. We know what's happening to it. What is causing that motion? What do you think? While people are thinking, I just want to check in. 24? What's 24? 24 what? What is 24? Should be 42. The answer is always 42.
Oh, true.
Yeah, it's always 42. Why 24? What's 24 telling me? Is force constant is one question. Let's just get your gut instinct. Force is constant. Who says yes? Just with no, you don't have to do any math. Just yes or no. Yes, force is constant. Force is not constant. Who says force is not constant? Why is force not constant? How do you know? What's changing?
It can change. It has the ability to change.
All forces could change, right? Change is the essence of life. It's a variety is the spice of life. But
Acceleration isn't constant.
acceleration isn't constant. How do we know that? Yeah. Acceleration is a function of time. Yeah.
If you take the position equation we'll give and take a second to look at that, you get the acceleration equation,
Okay.
which isn't a constant equation.
Okay. Yeah, so we know position, take one derivative. Now we have 3t squared, take another one, now we have acceleration, we have 6t. And then the 4t just disappears by that second derivative. So 6 times t is describing acceleration. So really it's like a constant jerk. The jerk is like a change in acceleration. So it would feel like the floor kind of dropped out from underneath you or something, but constantly, like it keeps changing. Okay, so let's see. What if I just say 6 times time? I'm gonna specifically say that it's a function. Oh, it's telling me that I did, because I got acceleration. It asked for force. Look at that. I should have read the problem. It's tough to do this up on stage. You forget things. Oh, it told you, that's where you got 24 at 2 seconds. Yeah, thanks. Nice. Yeah, I'm like, 24, what? No, it's gotta be something times time. Yeah, but you're right. It is at 2 seconds, which is what it asked for. F and, all right, let's just, so F is 4t, so at 3 seconds. So what did we want? 1.5 kilogram. So 1.5 times 4 times 3 is 12, 18. Let's see if it gives me credit for that. I'm just I was trying to wrap it up. Coming along. Oh my God, still another one? Okay, I was trying to wrap it up. 5 kilogram block by variable force. Alright, this one's cool. Okay, let's try it. So we have 5 kilogram block. Its force is 6 times x. No friction. Well, we already know what its force is. Doesn't matter if there's friction, right? Like if someone tells you this is the applied force, then whether or not there's friction is kind of like, I don't care. You deal with the friction. You already told me what the force was. So what happens at 2 meters? How fast is this thing moving when it gets to 2 meters? It starts at 0, goes to 2. How do we even deal with that? We might have to do some math. Everybody loves math, right? Let's see, what was it? 6x. F equals what? For Newton? MA? Yeah. So 6x is MA. So dv dt. What do I do with this now? if someone just randomly shouted out, chain rule, would that help?
Chain rule.
Chain rule. Chain rules. Does that help? No? Gotta chain rule this. Because you can't integrate x dt, right? I don't know what x is. X is some function of time. So, like dv, I can integrate dv. Calculus is great. It's just algebra with some extra, like, different, like, some limits in there. So I can say 6x dt is mdv. I didn't do anything crazy, right? But it didn't help because I can't integrate x over time because I don't know x as a function of time. Or maybe I do. Maybe I've, like, got insight from the force. Like, x is 42. Just, like, it just comes to me in a dream. So I gotta use chain rule. So I'm gonna take that dt, move it over here again, put a dx up here, and a dx down there. Yeah? So I just multiplied by, what is dx dt? Dx over dt. It's a trap. No, it's not a trap. It's just, it's what we've been talking about, like derivatives and positions and all that. Yeah.
X with respect to time.
X, yeah, X changing over time, which is the velocity. The velocity. dv dx times v all equal to 6x. Oop. Let me put the v in there. Have you seen this before? Does that look familiar? Chain rule. So sometimes I do this and people are like, that's not the chain rule. I'm like, that's definitely the chain rule. It's just, there's more than one way to, like, use the chain rule, but, like, multiplying by that dx over dx, that's definitely, like, chain rule, because you're just changing what integration you're doing. Like, rather than integrate over time, we're going to integrate over position, and just make the whole thing position and velocity rather than, like, time, position, and velocity. 0 to 2, v0 to v final. I don't remember what its initial, does anyone remember what the problem told us to do? We have how many kilograms it has. Zero to 2, it starts at rest, so we can say that this one is 0. What was the mass? 5. Two times 3 is 6, times 4, over 5, 24 over 5. I'm just going to write that in. What was it? 24 over 5. And I'm just putting in my math in there too. Reasoning is very close. Oh, it wants a work energy solution. Work energy would also work. It should be the same number though. Is it gonna give me a grade? Finally, it's the same answer. It just used work energy. And we'll get to that. Work energy is the same thing as integrating by parts. But okay, let's see. Oh my god, just give me just give me a grade. Give me a grade.
When I did it, it took like 8 or 9 questions.
It should be 4. I'm just telling it give me a grade, like I'm done. There. So now it's kind of covering some stuff and telling me that I have an A. Cool. At least based on what I've done so far, right? And like use this as you want. Like it's a tool. It can be helpful. It can also not be. So now that I've done this, just highlight this whole conversation. Just like this, and copy and paste that right into the Husky CT submission. There are other ways you can do it. Like I could go through line by line and say, like, put this into I forget the verbiage. Microsoft gets so complicated. There's so many different, it's so frustrating. But anyway, like, eventually you can like get stuff into a Word document online, and then you could post that Word document. But copy paste is fine. It just grabs HTML, posts it into HTML. We're good. How'd it go? A effort. B. It's like, well, yeah. And I know there's got to be questions still. I was getting, yeah, thanks.
Going back to the fourth problem you just did now,
Yeah.
I'm a little confused on the first few lines that you did. Could you just briefly explain your thought process on the calculus you did there?
Like how I knew that 6x. So there's kind of like this is step 1 of just, if I know what the force is, then I know what acceleration is. And it doesn't matter what function of force it is. Like that one has to be true regardless of what else. Even if someone said like force is going to be this logarithmic function that's raised to the power 3. It's like, okay, that's annoying, but F equals ma, so ma is logarithmic times logarithmic function. So that's my first step, and that one's just Newton's second law. Like, no, there shouldn't be like any thought process at that point. If you've already determined like what are the forces, then it's just plugging equations into F equals ma. So that the first step is nice there. The next step, because force is only a function of position, then I know, because I've solved these problems before, that I can't integrate x over t because there is no t there. Like there is no function x of t because I'm trying to find what is x of t. And there are other ways to do that. Is anyone taking differential equations or has taken in the process or already done? In the process? What are you at now? What are you up to now? Is it still first order diffie-qs? So everything looks like everything is dx dt equals some function of x and t. Okay, cool. That's a fun time. Those are good. Very helpful. Everything in this class is second order differential equations because f equals ma, and usually the end result is like what is the position, like where did it go. So when f equals ma, second derivative of x is now something, some force, some constant, some something. So usually we end up with second order diffie-qs. Yeah. Oh yeah, yeah, that's a great idea. Like if you have second order, so for the most part, MA is always some function of time, position, and velocity. It could be one of those three, or it could be a constant. Like even a constant is a function of time. It's just a boring function of time. Not as boring as zero. Zero is like the most boring. That's like not going out tonight, not even gonna call anyone, not even gonna check email. Like no Netflix and chill. Zero is just nothing and nothing. So even a constant is like Netflix and chill, like a constant something. So what you can do is this what you had what you were saying is like you could say v and a is some function of like some matrix times x and v.
Yeah, it's something like that. But like the second half of the DK class was like what they do in matrices. I can't off the top of my head remember.
Yeah, this is called that state space form. So the first row is like, how do I define velocity in terms of position velocity? Well, it's velocity, so it's 0 in the first column, and then a 1 in the second one. And then the next one down, where, at least in our case, we had a 6. What did we have? So we would say 6 times x. So we could say a 6 here and a 0 there. At least for this one case, we could say that it's 6 times x and then a 0 times velocity. And really it's like 6 over m, because I'm not saying that it's ma. Ma is not equal to a. Ma is still ma. Yeah, and this is a cool way to do it. But instead of doing like a matrix form, I was just trying to ignore the fact that there is time and just say if it's only velocity and position that are the main variables, then I can integrate directly like velocity and position. The AI correctly stated like, hey, you can use work energy form for that, and that would have worked just as well, because we would have said yeah, do we want to keep anyway, you asked about this one, so let's stick to this rather than saying like you could do this and this and this and this. Let's stick to one option. This was it. This is what we did. Let's stick to that. So this was like our main chain rule step. Was this part of the confusing part? Was like in that box? Like how do you know? When you know, you know. It never hurts to just throw in a couple of dx's. It's not going to change any. It doesn't like redefine physics or anything. It just usually usually makes the math a little bit easier. So here I knew that if I can get a dx dt on its own, then that is velocity. And then then this dx, I knew I could bring it over there. So, and part of this is just I've done it before and I knew it was gonna work. So the more you try it, the more it'll work out for you. It's, you know, how do you break a board with your hand? Just keep hitting the board until the board breaks. But
This is unrelated to this, but there's an assignment, the velocity of dynamics thing. What are
Yeah.
we supposed to do for that?
yeah, what are we supposed to do? Great question. Is that okay if we switch gears? Philosophy of dynamics. And this one, I'm looking at the, oh, we have submissions already. Can we pull up a submission to see what people did? Do you mind? I guess it'll be on YouTube. Yeah, I won't do it. I kind of want to do it, but at the same time, I'll give a little bit of privacy. So in here, main thing is, this is our first experiment with like doing some group activity. So there should be like 50 different groups to choose from. And we had a discussion last Friday before the storm about like this idea of Newton was using the laws of cause and effect, and he kind of set out what are the laws of physics, and we've been following that ever since then without questioning, like, is everything governed by cause and effect? So with your group, hopefully there's more than one opinion on that, because in the class there was tons of different opinions. You can try to get like your main message as a group of like what you all thought. You can also just kind of everyone add what they thought to it, but it's just kind of capturing a small piece of our conversation from that Friday. So it's not, there's no like solution to this, and believe it or not, we don't know if there's free will. We can't like prove it with an engineering equation. Chain rule, just use the chain rule. It's like free will, dot dx dx, and there we go. Free will is 6 times x. Yeah.
Individual submissions?
There shouldn't be individual submissions. I don't think so. Are there? I don't know. You tell me. Were there individual submissions? It should be 50 group. Like you should only be able to join one of 50 groups. Yeah, that should be how it works. Okay. Yeah.
No.
Yeah, part. What time is it? Do we have? We still have 5 more minutes. Cool. So what we could do is try to figure out groups with these last couple of minutes of like who's who. Then next time what we'll do is jump into, where'd it go? Oh, case problem 1. Friday we'll start looking at like our first case problem where we'll do some work together. So main thing here is you can always resubmit work. So even if you just try something, like you try to join a group, try to add something, if it doesn't work out, you can always resubmit or join a different group and then resubmit. I think you can join, I don't know. I don't know exactly how the groups work because I've only been on the creating part rather than the culminating part. But you can always resubmit any work in this class, so there's never a penalty for just going out there and trying something. Sound good? All right, thanks.